GTD, but now we are improving. Is it okay? Me as a teacher for fluid mechanics?
Yes, sir. Okay.
Yes,
Okay,
sir.
thank you. Okay. Now we have calculated CD, that is Q actual divided by Q theoretical, and is equal to 0.64. Okay. Okay. Now here we have to calculate another coefficient we can calculate by the given data. Which coefficient we can calculate directly with the help of given data? Anybody?
CV.
CV. Good. So what is meant by CV then? CV is equal to anybody? CV is equal to anybody? CV is equal to square root of we'll reply,
X
we'll take
square upon 4YH.
x square upon 4yh. This is why this formula we are taking in this way, because it is very easy to remember in one stroke. Square root of x square upon 4yh. Some books they were taken it as a 2x. Some books they are written that CV is equal to what? 2x divided by 2 into square root of yh. Or they have cancelled this 2. Sorry, not 2. X upon 2yh. X upon 2 into square root of yh. But this is very uncomfortable or inconvenience to remember. Therefore, in one stroke we can calculate, we can remember that square root of x square upon 4y. So this, therefore, we are taking this. Okay, now x we are knowing, y we are knowing, and h. So somebody can calculate and tell what is the value of CV. CV. Somebody have to calculate and tell me. Everything we are knowing. Shall I go to the previous slide? X is equal to 4.3, y is equal to 0.5, and h is equal to 10. So 4.3, somebody can write in chat box also, no problem. So 4.3 square 4.3 square divided by 4 into 0.5y into h. H is equal to how much? H is equal to 10. And CV is coming as anybody? CV is coming as CV. Nobody is calculating. What happens? Whether due to feedback link is broken. Okay. So Shubham Orikar got 0.96. Others please reply. This is asked for sometimes 7 marks. 0.96. I will considering. Anybody, any other value you are getting? 0.96. Okay, Ajit. 0.96. Balaji Pise. Okay. Many are getting. So 0.96 I will confirm. And then we got CD, we got CV. Okay. And then we have to calculate CC. Now, what is formula to calculate CC? Any relationship between CD, CV, and CC? We are knowing this relation. Anybody? CD is equal to CV into this relation. Everybody on tip of tongue we should have. CD is equal to CC into CV or CV into CC, and therefore CC is coming as CD divided by CV, and is coming as 0.66. 0.66. It is 0.6. Good. So understood by everybody this numerical. Understood. Shall we proceed next numerical? These are the numericals on hydraulic coefficients of an orifice and flow through orifice. So this kind of numerical sample 2, 3, 4 numericals I have taken. We'll go to the numericals on Venturimeter. Is it okay? Yes, or you can write. Yes means for understanding, for proceeding for next article. Yes, over. Okay. Yes, over. Good. Good. Thank you. Now, one Venturimeter simple numericals are there. We'll go one by one. Okay, I will take numerical. Otherwise, Okay, so this is numerical. Sorry. So an oil of specific gravity zero point 0.8 is flowing through a venturimeter. So this kind of numericals may be asked on the venturimeter. An oil of specific gravity zero point 0.8 is flowing through a venturimeter having inlet diameter 20 centimeter and diameter at the throat is 10 centimeter. Throat diameter is 10 centimeter. The oil mercury differential manometer shows reading of 25 centimeter. Calculate the discharge of oil through horizontal venturimeter. Take CD is equal to 0.98. This is numerical. So what is given? So what is given? Somebody can help me. Okay. So an oil is flowing through a pipe. So what is fluid flowing through the pipe? Anybody? What is fluid flowing through the pipe? Anybody? Oh, venturimeter or pipe. So pipe. This is a pipe. Okay. And for this, one venturimeter is connected. This is throat of the venturimeter. This is divergence section. Afterwards, this pipe. This pipe is connected to the horizontal venturimeter. This is our inlet section. This is our throat. So, what is flowing in this air? Oil is flowing. So, rho of oil or specific rate of oil they have given. SO. That is nothing but what? SO is given as 0.8. Okay. Then having inlet diameter. So diameter of throat pipe and this venturimeter is same. So inlet diameter is what we can calculate as a D1. And this D1 is equal to how much? So D1 is equal to here, anybody? 20 centimeters. So 20 centimeters is equal to 0.2 meter. So from this we can calculate area A1 pi by 4 D1 square. And how much it is coming? Somebody have to tell me. Like this, diameter at throat is D2 is 10 centimeters. So D2 is given as 10 centimeter is equal to 0.1 meter. And therefore A2 is coming as, what is the value of A2? Pi by 4 D2 square. So this A1, A2 we are getting now. S of oil is 0.8. Okay. And the oil mercury manometer. So in the this manometer is there. In the manometer, the manometric fluid is mercury. And we know the specific gravity of mercury is SH, is because it is heavier. What is specific gravity of mercury? Who will tell? At the time of first practical properties of fluids, we have defined specific gravity of mercury is, anybody? Manometric fluid is mercury because they have given manometer mercury. Mercury differential manometer. Oil mercury means in flowing fluid is oil, and in the mercury manometric fluid is mercury. And that SH is given as mercury specific gravity. Anybody? Somebody can reply.
13.60.
13.60 or 6. Correct. Good, Nikita. 13.6. Okay. So SO is given, SH is given. Now D2, the A1 we can calculate, A2 we can calculate. So anybody have calculated A1? And the oil mercury differential manometer shows reading of 25 centimeter. What is this given? 25 centimeter. So this is what? Pressure head difference with respect to mercury is given. Mercury means differential manometer directly it will give the reading of with respect to mercury. So therefore X were defined is as a what? X. So X they are given as a 25 centimeter or is equal to 0.25 meter, and CD they were given as a 0.98. Everybody understood this given data? As per our nomenclature in the derivations. So SO is 0.8, SH is 13.6, D1 is 20 centimeter, 0.2 meter, A1 is pi by 4 D1 square, D2 is 0.1 meter. So A2 we can calculate. Everybody understood this nomenclature as per our derivation. Now we have to calculate what they asked. Calculate discharge. As CD is given, so we have to calculate actual discharge. What is the value of actual discharge? Everybody understood this up to this given data? Please write yes and over. Please write yes and over. Okay. Genesher, good. Yes, good. Yes and over. Okay. Then we have to write the formula of actual discharge or theoretical discharge. You can calculate theoretical discharge. You are knowing the value of CD, and theoretical discharge is given by formula. What is formula of theoretical discharge? Anybody? Those are studying regularly, at least those can answer. The theoretical discharge through orifice through Venturimeter is given by. What is the formula? Derived I think this derivation. Somebody can tell. Unmute and tell. Somebody can tell A1, A2 divided by square root of. So this formula everybody should remember. A1 square minus A2 square into square root of 2GH. Am I right? But this is H is pressure head difference with respect to oil. Okay, so H is equal to what? Pressure head difference with respect to oil. Okay. Now, no problem to calculate A1, no problem to calculate A2. A1, A2 we can calculate. So H we have to calculate. Now, somebody have got the calculation of A1 and A2. What is the values of A1 and A2? Somebody can tell values of A1 is equal to or A2 is equal to chat box. Please fast. Please go fast. Then how I can? If you are not responding, and I have to take calculator with me and you have to solve. Write in chat box. Prathamesh. Okay. Shubham Porikar. A1 is 0.0314. A1 just I have to copy. So A1 is okay, calculated. Okay. Now H we have to calculate. Who will tell the value of H? What is value H case? Conversion of X. The X means we are getting with respect to manometer, we are getting the deflection. With respect to mercury, we are getting deflection. And that deflection we have to convert into H. And for that, we are having the formulas. Anybody? H is equal to, now this is which case is applicable? Case 1 or case 2? Chat box you mentioned. Those are understood. Why students? H is equal to case 1 or case 2. Manometric fluid is heavier than flowing fluid, or flowing fluid is heavier than manometric fluid. Is manometric fluid is heavier or manometric fluid is lighter? Mercury is heavier than oil. Means which case is applicable? Means mercury is manometric fluid. Which case is applicable? Anybody of you? First case. Very good, Nikita Pawar. Okay. Good. Case 1. Okay. Case 1. What is that case 1? H is equal to, very simple, X into bracket. Good. X into bracket SH upon SO minus 1. SH upon SO minus 1. So is equal to, so what is the X value? 0.25. Write down X is equal to, so 0.25. X is equal to 0.25 into bracket. SH is, somebody told, HSC specific gravity of mercury 13.6. Divided by specific gravity of oil is 1, sorry, 0.8, not 1, 0.8. If it is water, we can take it as specific gravity of 1 minus 1. And this H is given as, what is the value of H? Very simple numerical they are asking. H is equal to 4. H is equal to 4 meter of oil. Okay. Meter of oil. Okay. And this will, now you can put in this equation now A1, A2 and Q theoretically calculate. Q theoretical is equal to, now put all the values. G you are knowing 9.81, H you are knowing 4, and A1 we know, A2 we know, so A1 square minus A2 square. Put the values and calculate H. It will first will get in terms of meter cube per second. Okay, so tell me the value of Q theoretical. Put, now I am not writing. Everybody is knowing A1 value, A2 value. Now directly tell me the value of Q theoretical. Okay, so Shubham Andole got answer 0.1195. Point. Everybody agree? 0.1195 meter cube per second. Everybody agree with him? Shubham? 0.1195. Okay. If it is there, then CD, we know value of CD is equal to what? We want Q, not theoretical, we want Q actual. So CD is equal to Q actual divided by Q theoretical. And therefore Q actual is equal to Q actual is equal to CD into Q theoretical, and is equal to anybody know? 0.1195. CD is 0.98, is Venturimeter accurate device. Therefore CD is equal to 0.98. So CD is equal to point Q actual, Q CD is equal to Q CD 0.98 into Q theoretical. Somebody can tell value.
सर क्यू थेरॉटिकलची व्हॅल्यू आहे ना ती 0.071 येते.
0.071. Okay, so Nikita's value is 0.072. Okay, Bandgar is also, Rakesh is also getting same value. So 0.072. I will not consider this value then. We will majority is carrying the point. I will check. Okay, 0.072. This is your calculation, meter cube per second. And Q actual, Nikita, is coming as? Q actual is coming as, anybody? 0.6. 0.072. And Q actual then coming as? Somebody can chat box?
699.
0.699. 0.69. I got it. 0.699 unit is meter cube per second.
Sir, 0.0699.
0.0699. Okay. 0.0699. meter cube per second. But generally we measure discharge in terms of liter per second. So it should be multiplied by 1000. 1, 2, 3. It will be Q actually is coming as 69.9 liter per second. 69.9 liter per second. You would understand this numerical? Understood? Yes, Pramod Olekar is telling yes. Okay, yes, good. So such kind of numerical they may ask on the Venturimeter. Take it. Okay, we'll check the answers also. We are having that numerical in somewhere. Now we'll 1 or 2 numerical now directly we'll take from while 1 or 2 numerical will go for directly from this. Okay, this numerical was there from this one followed only. And answer is 70. Okay, let their answer is little bit different than our answer. 0.70, 70.44 for 6 liter per second. But throat diameter is 10. In our case also throat diameter is 10, na? A1. Okay, let it be little bit difference because of some. Okay, now another numerical. So we'll now directly I will tell this numerical. Horizontal numerical, sorry, horizontal venturimeter with inlet diameter 20 centimeter. So in D1 is given, throat diameter is 10 centimeter. Is used to measure the flow of oil of passive gravity 0.8. Same, okay. The discharge of oil through venturimeter is 60 liter per second. So now they have given discharge. Find the reading of oil mercury differential manometer. Take CD is equal to 0.8. So in this case, they have given that discharge Q actual they have given here. So if it is given in numerical, we have to consider this as a Q actual is given as 60 liter per second. So here they have given Q actual 60 liter per second, or in this case it is divided by 1000 then 0.06 meter cube per. Let they have given in centimeter square. We'll try it. We'll go for in meter cube. Our SI system. So D1 they have given 20 centimeter. So we can convert into meter. A1 we can calculate from that point not something whatever you have calculated. And D2 0.1. Okay. So this will be D2 is A2 we can calculate from this in meter square. Already we have calculated it. Then A2 is point. CD is given 0.98 is given CD. Okay, CD is given 0.98. So Q actual is 60 into 10 raised to 3 means Q CD is equal to, so that value. Now we want to calculate first, we will get value of H. So if we get that Q actual is equal to what? So directly we have to use the formula CD A1 A2 divided by square root of A1 square minus A2 square into square root of 2gh. This is our formula. Now in this formula, Q actually is we can calculate 0.06 meter cube per second. CD is given 0.98. A1 we can calculate, we are knowing from the diameters. A2 we can get it. A1, A2 we can get it. And H value is we can calculate. So first of all, we'll get the value of H in meter of oil. In our case, you see, they have used the CJ system in book. We will use our SI system. So meter of oil. So this will be 289 centimeters. So 2.8998. So 2.90 we can calculate. 2 point, near answer will come 2.9 meter of oil. And after getting this H, we know the formula H is equal to, case 1 is applicable, X into bracket SH upon SO minus 1. To put the value of H we are knowing, SH is we are knowing 13.6 mercury specific gravity, oil is there SO 0.8 we are knowing, and 1 we can do, okay, and X. In that case, X is coming as what? Here we will get answer in terms of first meter. So 0.18 meter of mercury. Everyone understood this numerical? Understood? Understood? Please write. Yes. Yes. So okay, I will give this write up to you. Such kind of numerical they may ask on the Venturimeter. Only one student give a response, responded. Now this PDF write up I will PDF notes I will give, as well as this notes also I will circulate. Anybody is having problem? Want to repeat the solution, etc. Only thing is there that we have to write our everything in our here numerical write down. Afterwards D1, D2, everything will write in SI unit. Afterwards, at last we will convert into required units. If Q actual we are getting in meter cube per second, we'll convert into liter per second. Here they have given Q in terms of liter per second. We will convert into meter cube per second. That way. Understood or don't waste. We can solve next numerical. I will providing these notes. Only one should reply. Others please reply. Nikita Pawar, Balaji Pise, Prathamesh Patil, Swas, Kunal, Shubham. Okay, yes. And why you're asking me to Diksha Mile? Okay, yeah. Everybody should. Okay. Now, is again one numerical. A 13. Okay, a 13 into 15 centimeter. So, if this kind of dimensions they are given 30 centimeter into 15 centimeter, the first diameter is always inlet diameter. Consider that. So, if it is given as 30 centimeter in 15, so maximum diameter is inlet diameter. So, in that case, we have to consider that first diameter is inlet diameter and second diameter is throat diameter, that is D2. So, D1 is given as 0.3 centimeter, 0.3 meter. D2 is given as 0.15. Accordingly, we can calculate A1 and A2. From diameters, we can calculate A1. From diameter, we can calculate A2 also, D2 diameter. Then is inserted in a vertical pipeline carrying water flowing in the upward direction. A differential mercury manometer. So whether vertical venturimeter is vertical or inclined or horizontal, formula is remains same. Okay. The differential mercury manometer means in the mercury manometer mercury is flowing. Okay, and inlet and throat gives a reading of 20 centimeter. So difference means what? Difference they are given. X is equal to 20 centimeter. So X is equal to given as 0.2 meter. Okay, and find the discharge. So Q actual, if it is CD, it is given then. First of all, we'll get Q theoretical, and we have to find out Q actual. So CD is equal to Q actual upon Q theoretical. And therefore, what we can call CD is equal to Q theoretical is equal to formula we are knowing. So A1, A2 we can calculate with the help of diameters. So Q theoretical is equal to A1, A2. For everybody have to remember this formula. Divided by square root of A1 square minus A2 square into square root of 2GH. So A1 we know from A2 H. What is H? Again, case 1 is applicable. Only few times we are using case 2. Otherwise, every time we are going to use case 1. H is equal to X into bracket SH upon SO minus 1. So X we are knowing 0.2, SH we are knowing 13.6. Yes, so water is flowing. So water is 1. SO in that case, or water, passive rate of water is always 1. So SO is equal to 1. So SH1, SOH will get, and if you get H value, you will get Q theoretical. After getting Q theoretical, CD is equal to Q actual divided by Q theoretical. Okay, so with the help of this way, one can solve the actual discharge. So today I think we'll stop here. Am I right? Understood this numerical? If you are telling yes, then I will send you these notes immediately after this lecture to you, PDF notes, so that now only Bernoulli numericals are remained. So 1 hour it is required, half an hour to okay. Next lecture we'll finish this and we'll start unit number 4. Is it okay? Write down yes and over chat box. Okay. Yes means you are agreeing everything. Okay. Now I want attendance first. Roll number 1.
Present, sir. Roll number 1. 2.
Yes, sir.
3. 3 absent. 4.
Yes, sir.
5 absent. 6. 7.
Yes, sir. 5, yes, sir.
5 also. 6 also. 7. 7. 8.
Yes, sir.
9.
Yes, sir.
10. 11.
Present, sir.
Swazji, not interactive nowadays. Swaz,
Yes, sir.
काय लक्ष असतंय की नाही?
असते, sir.
काय इंटरॅक्ट करत नाही आजकाल? कारण काय समजतंय का? श्वास
Yes, sir. समजलं.
ठेवलो.
Yes,
हा
sir.
श्वास. हा श्वास. हे ठेवलो. 12. 13. 14. 15. 16.
Present, sir.
16 present. 17.
Sir, 15 present.
15 present. Okay. 16 present. 17. 17. 18.
Yes, sir. 18.
Okay, Ajit. 19.
Yes, sir. 19 present.
20. 21.
Present, sir.
21 present. 22.
Yes, sir.
23. 24. 25. 26. 27.
Present, sir.
Okay. 28. 29,
Present, sir.
30, 30, 30, 31, 32,
Yes, sir. 32.
32, okay. 33,
Yes, sir.
34, 35,
Yes, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40, 40 absent, 41,
Present, sir.
42,
Present, sir. 42.
43,
Yes, sir.
44, 44,
44. Yes, sir.
45.
44. Yes, sir.
Okay, okay, I got 45,
Yes, sir.
46, 47,
Yes, sir. 47.
48, 47 actually present, 48,
47 present, sir.
actually I have taken, 48, 49,
Yes, sir.
50,
Yes, sir.
50, 49 present, 50,
Yes, sir. 50.
50 present, 51, 52, 53, 54, 55,
Yes, sir. 55.
56,
Yes, sir. 56.
57,
Present, sir. 57.
58,
Yes, sir. Present.
59,
Present, sir.
60,
Yes, sir.
60,
Yes, sir. 61.
61,
60
Yes,
present,
sir.
sir.
61, 60 present, 61
Yes, sir.
present, 62, 63, 64, 64, 65, okay, Rakesh, I got it. 65, 66, 67, 68, 69, 70 present.
Present.
Okay. Thank you, Ren. Those have not submitted their answer sheets of IS1, please today only you submit. Otherwise, I am not going to consider their attendance.